I don't think I've ever gotten such a nice introduction. They usually say, hey, there's this weirdo coming up here to give a talk, right? That was very nice, Dr. Gordon. I really appreciate that. And I want to welcome everybody here and kind of give you a little overview of what my plan is today for this presentation. The title is called Interdisciplinary Research in the Support of New Biomedical Discoveries. And what I'm going to talk about will be clinical trials as well as population-based studies, as well as building databases, and I'll give examples in physical therapy and also occupational therapy to try to show you that. So the overview will, first of all, begin with talking about the background, and then I'll talk about translational research and the training missions of our Department of Preventive Medicine, and which is, in a sense, a school of public health. And then I'll give you examples of translational interdisciplinary research where the key word is this collaboration with people like people in PT and OT who are really bright and have creative ideas. And we'll talk about how this leads to clinical trials and population-based studies. Then I'll talk about the role of biomedical informatics, and then a little bit more about translational research, and then end up with some music jokes. So the background. So what was my training and experience? Now, I'm sorry to use this word, but I went to UCLA, and I majored in mathematics with a minor and minored in music. And after completing my master's degree, I didn't know whether I wanted to go on for a PhD in mathematics and end up sitting in the corner deriving theorems and stuff like that. So I was grabbed up by the RAND Corporation, by the famous mathematician who ended up at USC named Richard Bellman. He was like probably the world's most famous mathematician. And I worked with him on some mathematical papers, but then also on the so-called ARPANET, which was the Defense Network communication system, and that led to the Internet. It was, the URL was developed for that and everything like that, and who knew then that would be what would happen. And then when I was 22 years old, for some crazy reason, I was asked to write music for a documentary film on autism called The World Outside. It was about a blind autistic kid and how he was treated and finally overcame his autism. So in modern times, he probably wouldn't be called autistic, but he behaved autistically. And it won an award at the Cannes Film Festival. Now this is what I looked like as a 25-year-old hippie sitting on the beach in Santa Monica saying, hey, are there any girls around here? Probably that's what I was doing. I don't remember. And then when I was 23 years old, I wrote music for a French play, Ubuwa, which was performed in Paris in 1896, where people either loved it or hated it because it was like ending Shakespearean plays and leading to kind of unusual, weird plays. And so Ubuwa was the first thing that ended the traditional French theater, which would be like Victor Hugo or Shakespeare, and paved the way to Théâtre d'Absurde, the unusual thing. And in Paris, in 1896, people either loved it or hated it, but the beauty of it is that it led to kind of modern theater in Paris. And so what we decided to do when I was 23 years old is decide, do you think people in the United States and California will love it or hate it just like they did in Paris? So we did an English version of it, and indeed, people either loved it or hated it. But it was reviewed by Time magazine, and we got a good review. And then what's really interesting is that the Getty Museum is going to be housing the music that I wrote for that play. Then I returned to UCLA when I heard about this new thing called Biostatistics in the School of Public Health. And after graduation from that with a PhD, I sat on the beach in Santa Monica and said, what do I do next? And that is kind of a thing for the postdocs here, because you finished your PhDs and now you're doing a postdoc. But you know, the beauty of it is that you start networking and you find out what the next step in your life is going to be. And so I, interestingly enough, was recruited by USC to build a interdisciplinary program in preventive medicine. At that time, there was only 5 faculty in the department, and it was called community medicine then, and over the years it's grown and grown and grown. and has 122 faculty. So my bad joke is, when people ask me, hey, as a UCLA graduate teaching at USC, who do you root for at the USC versus UCLA football games? Answer, well, it's a matter of alma mater versus bread and butter. So what do you think wins? Okay, so so let me give you an idea of translational research and the training mission of the Department of Preventive Medicine. So the research programs in the Department of Preventive Medicine, it was primarily initially involved in cancer, and then over the years we got more and more interdisciplinary, and cardiovascular, diabetes, ophthalmology, obesity, Alzheimer's, and then one of the great areas is in this rehabilitation science, where I've had the honor of working with both the OT and the PT departments. And, you know, I don't know whether you know it, but Carol Lee Winstein was one of my students in the early days. And she was a shy person then, but boy, she's not now. She's my boss. Research combines biostatistics, bioinformatics, clinical medicine, basic and laboratory science, and health behavior. And it does have an international component. There's studies not only in the U.S., but Europe, China, Thailand, Singapore, and it's growing more with this global health program. And typically, in terms of research grants, we've been ranked number 1 or number 2 in the United States in the last 4 or 5 years. So that's pretty good. Now, what about training? Well, I was involved with building the training programs and the MPH. Well, the first were these master's degree in biostatistics and epidemiology, but then over the years, we recognized the need to have a laboratory-based epidemiology thing that became molecular epidemiology and statistical genetics, and then this master's of the public health degree became really an important way, and there are these different tracks where students can do biostat, epi, community outreach, global health, et cetera, and so on. And then I built this MD, MS program in clinical and biomedical research, and a number of the postdocs had started enrolling in that program. And I'll quickly describe what it is. It's a Keck school program, but now I've brought, Payne from the dental school, so we have Keck School of Medicine as well as the dental school involvement. It's a track-based program where you pick a track based on your passion and your interest. So it could be community outreach, it could be global health, it could be clinical trials. And the other thing is that there's a track called alternative. So you just pick what you want. So like 4 courses that you want. In the first year, you take these 4 courses, and they tend to meet like once a week so that you can do your clinical research or your research or your clinical involvement or whatever in addition to the class. And then in the second year, what you do is with your mentor and with the committee, that's when you start writing papers and or a grant proposal and so on. And there have been a lot of success stories of people who got promoted or got hired as junior faculty and so on. And the beauty of it is that it's a minimal number of units, coursework, and the rest of it is kind of working on projects and writing papers. Oh, yeah, but now it's... Yeah, and I should probably change that slide. Initially, it was begun that way because it was headed by that MD, PhD office. But now it definitely is it's much more now because not only is it in all sorts of different departments, like there's social work, engineering people in it, and also there are now, with the new CETCD, that's the Translational Center, there are pre-docs that are in the program. So this slide is what the original thing was, but now I should really augment that by saying it trains pre-docs and postdocs who are getting the pre-docs getting a PhD in maybe biology or something totally different, but then they need this kind of clinical and translational involvement, so they do like a joint MS and PhD degree. And then postdocs who have already graduated but now need this additional help. And there are courses in the School of Social Work and other departments that can be taken for that. And all the programs emphasize traditional textbook learning, but in addition, hands-on experience. And students are tested both on theory and applications. and typically they're funded down the line on research projects. Okay, so here's some of my other bad jokes, and then I'll get to some examples. So what about transferring knowledge? So when I just started at USC, all of a sudden I got this inspiration to write a book talking about using the first computer program software to analyze medical data. And I co-authored that with my PhD advisor, Professor Efficacy from UCLA. And the program was called BMDP, which was one of the first. Carol Lee probably remembers it. But it was one of the first packages to analyze medical data, clinical data. And that book was published. And another weird thing is that book, I had to handwrite the book. There weren't any, and there's like a pile of paper. This all handwritten. Then I'd give it to the secretary to type it, and then it would be sent to the publisher for printing. I just got a call about 3 months ago from some girl in Germany. She apparently was my secretary when I wrote the book. She called and said, "Do you remember me? I typed everything that you hand wrote." And she said, "And now I'm in Germany because I met a German guy, and now I got married, and I moved all my boxes there." And she opened up the box and discovered she had my handwritten copy of it. Anyway, so it's been translated into Russian and Chinese. And I'm also the founding editor of an international journal in computing and statistics. It's published by Elsevier in the Netherlands. And there's a website that houses links and reviews of software programs, algorithms, and so on. Now, here's my second bad joke, which was when I wrote this book with Professor Efficacy, we would go to his house and sketch out what the next chapter would be. And every time we did it, we would have a glass of Jack Daniels, bourbon, just to kind of unwind. We'd sketch things out, and then the next day I would come to my USC campus, USC office on the engineering school campus. And anyway, the bottom line is I really feel guilty that Jack Daniels wasn't given credit for this book. So I would like to rethink that. Is that pretty silly? Bad joke number 2. Okay, and then here's the journal. And my co-editor, who handles Middle East and European submissions, is given in this picture here. His name is Eric Spunter Georges. And he and I, when we get together, we're very good communicators, and we have like similar bad jokes and so on. And this is the website. Okay, so what examples of translational research? So the NIH roadmap says, let's create new knowledge from bench to bedside to the community. So the key idea is that you discover something in the laboratory, then maybe you'll do animal studies, then you'll do clinical trials, and then if things work, then you try to get this out to the community who doesn't know about these particular things. So it requires interdisciplinary research team, and it's a partnering with clinical scholars, physicians, socioeconomic experts, computational experts. So here's my famous graph of a translational study. So the first thing is you have a case report, and if on the case you learn that this works, then you do maybe an observational study where you see whether it works in a group of people. And if it does, then you kind of then come up with some biological hypothesis of why does it work. And then you do animal studies. And if that shows a good outcome, then you do a clinical trial. And that clinical trial, so you hypothesis test, and if that works out, then you now reach out to the community again and explain what's going on. So one of the very, very first translational studies I worked on when I just started at USC was called the cholesterol-lowering atherosclerosis study, CLASS. The basis of that study, and the lead person was David Blankenhorn, who passed away about 10 years ago. At that time, it was shown that animal studies suggested if you decreased your cholesterol level, this resulted in cardio protection. So CLASS was the first human study to assess the effects of lipid-lowering therapy, which at that time was no new drug, but using clostopol and niacin on coronary artery disease. And it showed that it did have the same impact on humans. It was published in JAMA and translated into 6 languages. And it was the first study to show that you could use a surrogate marker, which Jet Propulsion Laboratory developed, which is to measure the thickness of the crowded arteries and see whether that progressed or got better or worse over a 2-year period. And that was a surrogate measure for whether you had a heart attack 10 years later. So what I'm saying in English, this clinical trial didn't require us doing a 10, 20-year study to see whether this approach was appropriate. We did just a 2-year study where we looked to see whether the arteries would open or close, and then we did show in a follow-up study that closure of the arteries was predictive of that heart attack. So it was the first class was the first study to show that surrogate markers, the thickness, predicts future coronary events, and that was also published in JAMA. The class design applied to a second clinical trial. So this is really this translational thing. See, we didn't use any new drug. We just used other things that could reduce cholesterol. And then we were funded by Merck, well, funded by the NIH, but the drug called lovastatin, which is now called, I'm just walking on it, is it Mevacor? Is it Mevacor? Lovastatin, yeah, anyway. Yeah, Mevacor is the new name. So they developed this new drug, and then we were funded by NIH to test out this new drug. So it did show that Mevacor really worked, or lovastatin really worked, and so that led to the FDA approving that drug. And then we just kept going on and on and on, and we were looking at the impact of vitamin E in terms of preventing atherosclerosis, vitamin D, estrogen in the prevention of atherosclerosis, and phytoestrogens in progression of atherosclerosis. So we keep getting NIH funding based on this kind of clinical trial experience and showing that we know how to run a clinical trial and how we got good, interesting outcomes, and that led to additional funding, and so on. Now, a total different thing from a clinical trial was what's called an observational study, and we were funded by the NIH to do something called the South Bay Heart Watch study, which took place it's in like the Torrance, near the airport area. That's the South Bay Heart Watch. And so it was an NIH-funded study to see whether computed tomography coronary calcium scores predicted the risk of cardiovascular events in a multi-ethnic cohort living in Los Angeles. And that was ultimately published in Journal of American Medical Association also. And South Bay Heart Watch demonstrated that the coronary artery calcium score, combined with the famous Framingham score, increased the predictability in asymptomatic people. In other words, the Framingham score says, blood pressure, family history, cholesterol levels, HDL levels, and so on. And we showed that if you knew what the calcium deposits were, we could improve that predictability. And that was published as a lead article in JAMA. And what did we learn? What happened? It led to establishing coronary calcium screening programs internationally. So it led to screening. So this had public health impact. And what's interesting now is the New York guy who founded the whole study, Italian roots from New York, at age 65, decided he was going to learn Chinese. So he studied Mandarin and Cantonese, and then now is doing similar studies in the rural districts of China. And so some of the MPH students who are in that global health program at USC have applied for internships and have gone to China to work on those studies. So now population-based study is another type of thing. And even though I realize clinical trials is one of the main things we want to focus on, I think it's important to see the differences. So one of the population-based studies that we've been funded for, joint with the Doheny Eye Institute, is to look at ocular disease in Latinos. So it's called the Los Angeles Latino Eye Study, LALES. And LALES 1 looked at the prevalence of ocular disease. And the ocular diseases are diabetic retinopathy, visual impairment, AMD, age-related macular degeneration, and glaucoma were the primary ones. So to look at the prevalence, and then when we published about 40 papers on that, then we were funded for LAILS 2, which then looked at the 4-year incidence of ocular disease among Latinos age 40 or older. And the location of this is in La Puente, in the Los Angeles County area. And we picked La Puente, and this is an important thing, because the demographics of the Latinos there were similar to the demographics in the CDC, the Center for Disease Control. So age distribution, the income levels, et cetera, and so on, fit the national standards. So that's what I mean by population-based. Even though we used one city to collect data, it kind of was representative of the nationwide thing. So another goal is to look at risk factors and the degree to which these factors may be associated with visual impairment and the prevalence of ocular disease. And risk factors could be things like smoking, alcohol consumption, it could be lack of exercise, et cetera, and things like that. And then to determine the impact of ocular disease on, and this fits with the modern standard in clinical trials also, which is it's not enough just to see whether all of a sudden you can lift your arm better, but how does the intervention affect your quality of life? In other words, if you improve, but you feel lousy, these are two important factors. So we did show that we did do a bunch of studies that showed how the ocular disease and visual impairment related to health-related quality of life, like driving abilities, being socially involved, mental health, etc. And so then the other thing from a public health perspective is to evaluate utilization and barriers. In other words, let's suppose somebody is told, oh, you really need to see a doctor every 6 months because you have diabetes and you're at risk, and they don't do it. So we try to understand what the barriers are. Is it money? Is it not knowing where to go? Is it language, feeling insecure talking English instead of Spanish, and so on. So we've had a number of public health impact findings which basically show that Latinos living in the United States have high rates of eye disease, and a significant number may be unaware of their eye disease. For example, 1 in 5 individuals with diabetes were newly diagnosed, and 25% were found to have diabetic retinopathy. And overall, almost 50% of all Latinos with diabetes had diabetic retinopathy. And among those with any signs of age-related macular degeneration, only 57% ever reported visiting an eye care practitioner, and only 21% did so annually. And 75% of Latinos with glaucoma and ocular hypertension were undiagnosed before participating in LAILS. So this shows the barriers and the need to change the recommendations. So the bottom line message is programs should target people with less education who lack health vision insurance to reduce the number of people with type 2 diabetes who are not following current national guidelines for vision care. And the LAILS study now has been funded to look at 8-year incidence and also look at the genetic times environmental interactions. So we're collecting DNA samples. We're working with Cedars-Sinai to analyze the DNA samples, and we're going to be looking for genetic factors as well as these environmental factors like air pollution or drinking, the things like that, and try to see what the impact of the combination of those things are. So this is an example of the emergence of translational epidemiology from scientific discovery. And this was recently published in a journal of epidemiology, saying that the recent emphasis on translational research so this is not a clinical trial, but in epidemiology and translating things is, first of all, to explore the role of the test used to guide interventions, and then to evaluate the efficacy of a candidate application by using observational studies, then to assess facilitators for implementation, and then to assess the impact of the facilitator. And what we did in this, and Stephen Sen was involved in this, and Cheryl Vigan was involved in this, was we decided to try to improve the screening process for glaucoma. So one of the things that we knew was that standard tests using traditional cut points, Humphrey, frequency, intraocular pressure, etc., showed that when we did logistic regression to indicate what the best predictor was and what the specificity and sensitivity was, we learned that the cup-to-disc ratio, followed by expert visual field reading, and were the best measures. And what was the sensitivity was incredibly low, only it was as low as 0.3, which means the likelihood of predicting they really have glaucoma is only 0.3. It could be as large as 0.8 if you looked at a bunch of things. So we said, if these, what people think predict glaucoma are not good predictors. So what we did was we did what's called data mining. And this is the other thing that's really important for me to get across in this talk, is that one of the beauties of working with people that have large databases, from studies that they've done, is to say, hey, I'm interested in knowing a little bit about this. Do you mind if I work with you in your database to kind of mine it to see whether there's this kind of interesting relationship, or we can come up with a better screening process? So Cheryl Vigan, who's now faculty in OT, explored the benefit of using classification regression tree, CART, to develop an optimal screening algorithm. And it chooses the best cut point for each predictor and determines the need for additional predictors. And when we use that CART model, we increase that sensitivity from 0.38 to 0.92. So it jumped up dramatically. And Stephen Sen's dissertation was related to the CART thing, so he was the horse that drove the cart, or whatever the expression is. And this is Cheryl doing the work. And so we learned that the cup-to-disc ratio still was the best. And if it was less than 0.7, it said, okay, we need now to look at the visual field and get an opinion on that. And if it was normal, hey, no glaucoma. But if it was abnormal, we still needed to look at the intraocular pressure, which is one of the more traditional things. And if that was less than 14, no glaucoma. We're finished. If greater than 14, glaucoma. Now, if the cup-to-disc ratio was greater than that 0.7, so that's the other tree, a branch, then you needed to look at the hemophil test, glaucoma hemophil test. If it was normal, we still needed to look at the visual fields, and if it was normal, hey, no glaucoma. If the hemophil test was abnormal, then whammo, you got glaucoma. So anyway, these were the different things, and that's just been published about a couple of weeks ago in one of the main ophthalmology journals. So let's see. Yeah, I would think that the larger the N, the better. There is no kind of, statistical thing that says, hey, you need at least this. But I think that even if you started using this approach and you found out that all of a sudden everything, after you did the first split, you get like 2 people, and and then that would show you that these other measures are not very reliable or valid. Stephen, you have an answer to that question? Yeah. So in other words, it's a kind of another strategy given the sample size question. I mean, clearly you need a reasonable sample size, but it isn't just enough to do it once and say, hey, this is it. But you do this kind of bootstrapping type approach, which to take a random sample test it, come up with an algorithm, and then test it on the other remaining people. And that is an important kind of way to kind of validate what's going on. Okay, health promotion. So now we come to the famous Well Elderly Lifestyle Redesign Program. And Florence Clark, who's not here today, I actually was on her PhD committee, interestingly enough, and I remember her as being another shy person. And now she and Carol Lee both compete to be my bosses. So this health promotion is another clinical trial, but it's more in terms of a lifestyle redesign intervention. So it took a cohort of 400 elders, were randomized to, so the basic idea was, is there an intervention that you can use for older people after they retire that will improve their quality of life and keep them functioning and happy? And I do like to always give one example, a case study, which was my mommy. My mother complained all of her life that she never had a chance for a college education because her father and my father said, women don't go to college. They cook, sew, have kids, and that's it. You know, she came from that generation where that was, it seemed like the early 1900s and so on. There was more of this idea that women don't go to school. In fact, even when I taught medical school the first time, there were only 5 women in the class, and now it's about 60% women, maybe even more. But anyway, so my mother complained, and my father didn't want her to be smarter than him. So the bottom line is when she retired from her job at age 68, I forced her to start the University of California at Santa Cruz. She got her paperwork together, loved it so much, guess what? At age 78, she got her doctorate in comparative literature and did a summer abroad in Oxford. During that whole period, she was incredibly happy. You know, kids would come running to her and say, oh, can you help me? Should I date this guy or whatever? You know, so she would have this kind of, friendship and emotional type thing. And then other funny thing that happened, see, I was on her paperwork as the parent, even though I was the, so I got a letter one day in the mail saying, dear parent, don't worry about the marijuana scare at Santa Cruz. It's all right. As if I could see my mother just sitting there smoking marijuana. So the interesting thing is, and then she published her autobiography when she was 89 years old, and it is really incredible that she was able to do that. And so this is a good lifestyle redesign thing in terms of improving. Okay, so what we did was we took 400 people who were randomized to no intervention, so that's a control group, a social group, meaning, hey, let's go out and play bingo, or let's go to a movie, or let's go to the beach, and a lifestyle redesign group where each person was asked, what is it you've always wanted to do, and now that you're retired, you can do it. And everybody would have something, gardening, more active in the church, learning to sew things or whatever. Well, why don't you do it? And then they wouldn't know how to do it. And so what this program did was help them achieve that goal. And what we did was it demonstrated that a lifestyle redesign intervention reduced declines in health, function, and quality of life domains among low-income, ethnically diverse elders. In the original cohort, it was Caucasian and Latinos and Chinese, and African Americans in there too. Yeah, but they lived in retirement homes, so they had a little more income, and I'll mention that in a minute. So this lifestyle redesign intervention really did do it. Then we worked with Joel Hay here in the pharmacoeconomics group to do a cost-benefit analysis, which demonstrated the cost-effectiveness so that it was cost-effective. And what's interesting is the research was published as a lead article in the Journal of the American Medical Association, and it appeared on national television. Florence Clark gave a kind of a little talk on there, and we got a Nielsen rating of 12.1 million people saw the results of the study, and that's terrific for USC and for this and for OT and the PT department that made this thing. So then we got funded to do a second version of it called Well Elderly Number 2, which was to take a lower income population, a more diverse population, people that didn't live in retirement homes, and see whether this lifestyle redesign intervention was effective. And but also to try to understand what the biomarkers were. Okay, if you're feeling happier, what kind of changes occur? Like what other things are going on that kind of trigger whether you're getting happier? So so we also developed. I'm trying to think of a simple way to say it. Like modeling, structure modeling approach to say, hey, if you're happier because you're in this program, this will affect this marker or that marker, and then that marker will make you be more active, et cetera, and so on. So the bottom line is, the constructs include participation in health-inducing activity, coping, social support, et cetera. And we did come up with a graph which we presented at a national meeting that talked about how the program did affect your activity levels, and that affected your quality of life. But if the program didn't affect that, then if you had social support and perceived control, that could affect your outcomes, reduce your depression, improve your mental and physical things. The global impact of this study is that the British government has adopted it, and it's I forget what it's called, but when somebody retires, they're given that opportunity of going through this lifestyle design thing, and you can see that it's probably financial, because if people feel happier and so on, then they don't need to go to doctors, and hence it reduces expenses that the government would have to pay. So then a totally different thing is just look at health behavior, and so we were funded to do the Keck study, which is Transdisciplinary Research on Energetics, in which we examined ethnic differences in cancer-related metabolic risk factors in overweight African American and Hispanic children, and to examine the role of strength training as an innovative approach to improve these factors. Another project is to determine physiological and psychological determinants of the decline in physical activity in African American and Latina reaching puberty. And project 3 was to look at the neighborhood environment. So this is that kind of spatial statistics on genetic trajectories in a cohort of 11,700 children from 13 communities in Southern California. And this trajectory is the temporal progression towards overweight and obesity. And so we use fancy geographic information systems. We worked with people on the other campus in these, I think they call it the spatial statistics department. And we did look at neighborhoods in the Los Angeles area to see what kind of impact it had. And we did find that higher neighborhood connectivity, density, and land use will reduce the progression. Well, let's just go here. So we did look at street connectivity and population density, food access, like you see McDonald's signs everywhere you go, traffic around the home, and all these things. And we did produce a series of results which showed that certain things reduce the impact on BMI for 18-year-old kids and boys. Maybe it increased it for girls and so on. And so this work was published. And the beauty of this was it tied together a kind of a population-based approach along with some intervention approaches. So there was the clinical trial part of it. And then it also looked at these fancy statistical methods using the statistical information systems. So then now, over 2/3 the way through, as far as I understand, we looked at biomedical informatics. What is the role of that? So a lot of this was triggered by Carol E. Lindstein, and you'll see what it is. But this and I should also say, by the way, the biomedical informatics has a number of different ways of saying what it means. So biomedical informatics can mean like setting up clinical trials that have competency and can be combined with other clinical trials, et cetera. So that's more like medical informatics. The other idea of biomedical informatics is doing genetic research. So sometimes informatics can be just setting up really beautiful databases so that you can answer the questions that you're proposing to do, but then you can merge data from different data sets and come up with maybe more profound observations. So that doesn't have genetics associated with it. But then other examples are to look at not only the phenotypic, but the genotype data also. So the current efforts to mount clinical trials are enormous. The case report forms and systems developed with each trial. In the past, and it's changing dramatically, there were a lack of standards. So it hampers the ability to design and analyze trials effectively, to automate decision support tools, to share information across trials, which is a really hot area, and to mount new and multi-center trials rapidly. And so future trials will require not only the clinical information, but also the genomic data, and which would increase the challenge even further. In other words, a certain drug may be really good for this type of person from a genetic perspective, but not this type of person from a genetic perspective. In other words, there may be certain genetic factors that say, no, you should really use the other drug, not this one, and so on. So the NIH roadmap for translational medical research has the goal to build integrated research networks of academic centers linked to community-based care providers, to form partnerships that allow clinically relevant research to be carried out in an effective and efficient manner. And it's critical to develop efficient, scalable data systems to support the critical research into new treatment and prevention. And translational research is even more complex, and many studies are now multi-centered. Now, there's a lot of international standards in vocabulary and information models. The Health Level 7, HL7, is a regulated clinical research information model. There's the CA-BIG, there's the Bridge model, but the most important one is that last one that I mentioned there, which could have impact on the postdocs in here, which is International Classification of Functions, which is to look not only at the impact of a trial and improving your functionability and health, but also to see whether it's impacting your quality of life. So this ICF model was established by the World Health Assembly in 2001, and the rationale is that clinical outcomes has progressed from focusing exclusively on the impairment level to outcomes at the activity and participation level. So that's quality of life and activities and so on. So it isn't enough just to say, hey, you improved. It's, are you happier now, and so on. So an example of a scalable data system was the Physical Therapy Clinical Research Network, PT-ClinResNet, which supports a clinical research network assessing outcomes following evidence-based physical therapy intervention across and within 4 disability groups. Carol Lee was instrumental in getting this funded by the Foundation for Physical Therapy. I think I actually flew back for the presentations. I think I was a little nervous, but and it did incorporate the ICF standards so that it does look at quality of life. And it's metadata-driven system, meaning that you can combine data from different centers. Everything's coded the same way, so you can merge things and so on. And the rationale for this thing was that rehabilitation medicine has become a significant field, but the limited research capacity threatens its future impact. So the foundation gave funds in 2002 to develop a clinical research network supporting the effectiveness of physical rehabilitation interventions. And when we put this together, I should say Carol Lee, but our group did the database development. It consists of 1 coordinating center, 5 primary satellite sites, and 2 sets of outpatient clinics. So here's the fancy network, which I'm sure a lot of you have seen. Hi there, Kathy. And it has on there, it has things which are kind of public related, like what's new, the conferences, here's job opportunities, and so on. But then it has a secure area, which is where the databases are stored, and somebody can't just go on without having a password to look at the data. So this PT ClinResNet allows for centralized project design, project management and data analysis across disease groups. It provides standardized project protocols and data collection instruments. It provides comprehensive reports on project progress, participant safety, data completeness. Now, one of the new concepts, which not new, it's been around for about 5 or 6 years, is this concept of a data dictionary. A data dictionary should not just be developed by the statistician or the clinician, but it needs to be a cooperative thing so that the things hold up for the analytic part of it as well as the data collection part of it. So, so a data dictionary is to come up with like a list of what are the variables. Are they numeric, date, or character? Are they allowable, and what are the missing codes? In other words, if something is missing, you may get a message saying, hey, you've got to fill this in. What is the range? What is the field length? Is the variable required? And what is the question as it appears on the form? And then keeping track of the changes that are made, so the versioning, and then the data set name. So in other words, in the old days, we would get people coming running to our office and say, and give us an Excel spreadsheet to do the analysis. And nothing, and even though it did have the data on there, there was no kind of way to make sure the data fit the ranges that it was supposed to be. There was nothing to do, having to do with, well, what if it's missing? What do we do? And, how do we handle it? And then somebody else comes in with an Excel spreadsheet and they say, hey, let's merge these two. And the Excel spreadsheet's totally different from the other one. So we have to then write programs to say, if it's study 1, gender is male and female, male being 1 and female being 2. And study 2 says male is 0 and female is 1, or male is M and female is F, So to merge things, it requires this common data dictionary. So, and then the data mart is another idea, which is that, suppose you want to now do analysis, so you go into that fancy fat database and you pluck the things that you need for the analysis, and then you export it to SAS or SPSS or Excel. So, well, I probably shouldn't use Excel for analysis, but SPSS, SAS, or Stata. And the accomplishments were that it successfully leveraged the network instruction to rapidly deploy additional NIH fundings in rehabilitation, and as many of you know, the LEAP study, which Pam Duncan at now Wake Forest, Kathy Sullivan, I think I know who she is. She's sitting back there, and Berman, and some weird guy named Azen, I forget who he is, and there are many other people involved. I was just probably trying to spell it alphabetically or something. Anyway, so that was the LEAP study, which was a locomotor experience applied post-stroke study. And that was about a $13 million study over 5 years. And that's completed, and the main paper has now been published in the New England Journal of Medicine. And the eye care study is what Carol Lee Winstein developed jointly with Wolf, Dromerick, and Annie Zhang at that time. And it's an interdisciplinary comprehensive arm rehabilitation evaluation. That's $11 million or so over 5 years. And it's in, what, the 4th year now, or 3rd year? Fourth year, yeah. And some of the modeling type approach was similar to the LEAPS thing, but there still were a number of different variables and things that had to be done in a different way. And one of the things I could do down the line in one of these presentations is kind of walk through all the complexity of putting something like eye care together or LEAPS together in terms of tracking adverse events, making sure everybody knows there's an adverse event, sending it to the right overseer to see whether there's something where the trial is, causing problems, et cetera, and so on. So we could do something like that, and with LEAPS, since the study's been published now, I probably could kind of show you what the design was and what the sample size needs were and so on. So the recommendations is to build research infrastructure with reuse in mind, maintain consistencies, adopt and deploy standards, and recruit expert clinical scientists who understand the nature of interdisciplinary collaboration, and to consider many of the hidden costs associated with running the networks. See, there are all sorts of things that emerge, or we didn't know that at the time we put the proposal together, that require ancillary analyses and so on. So in terms of training, we need to develop integrated, centralized home, physical and virtual for clinical and translational research training. We need to immerse doctoral students, doctoral level academic professions, etc., into project-oriented training that focus on the fundamentals and culture of clinical and translational research. And the team effort is the key word there, in which you get people together from different areas and work on, coming up with a multicultural research project. So it's theme-based. So you might have an engineer, a clinician, a statistician, etc. And then this ends basically my thing, except for the music. And how do I do that? Click on it really. Okay, so as you all know, music is important because you recognize the importance of lifestyle balance, left side, right side of the brain. And a lot of the mathematicians I grew up with were also musicians. And a recent article published in Hypertension shows that in California, people who work more than 50 hours per week are 29% more likely to develop hypertension. So, oops, okay. So this is the anthem. That sponsors my journal. That's the SDA, where you saw me with the Greek guy smiling. And when I became president of the IAC, I forgot that one of my missions was to write an anthem. So when I was turning over my presidency, I panicked. I said, oh, we got to write an anthem. So my wife, who I call Vanna White here, Joyce Nyland, who has a PhD, actually she has a master's in physical therapy and biokinesiology, and then she got a PhD in biostatistics. Now directs research at City of Hope National Cancer Center. So she sat down and started writing those lyrics that you just saw, and that triggered me to write the tune. And then I got some guy to do some bossa nova version of it, and we performed it at the Opera House in Sydney, Australia. So that's really incredible. So should we do it one more? Should we do it one more time? Go back? Okay, because the thing that I'd like to ask you to do is now I'd like for you to sing. Okay? How's the music going? Oh, maybe. Okay. 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 So it's not a typical lecture, is it? Okay, so are there any questions that I can answer, or any thoughts or things like that? Yeah, Kathy. Oop. It just almost fell. I think I will sit down here, though. Okay. Yeah, Kathy. Yeah, so this is actually, the basic concept is important here for those of you that will be involved in clinical trials, is that to get funded for a clinical trial, you have to have a hypothesis, or at least one main hypothesis, one or two main outcomes. You have to have some pilot information about, what you think the outcomes are going to be, and some power calculations showing, and then a standard design, and the design could be randomizing to treatment A versus treatment B, or it could be randomizing within groups like the stroke severity, A versus B, or whatever, okay? And then you need to have an analytic plan for what you're going to do. So to get funded, that's expected at the National Institutes of Health level, and for a phase 3 trial, yeah, that's the basic idea. Phase 1 and phase 2 can be more of the exploratory thing. So when you're funded for that, and you get to the final thing, you basically have to kind of follow the design and the analytic plan that you've laid out. And if you find things that are not as exciting as you expected, then after that initial paper is done, then the idea of doing secondary analyses is permitted, as long as an oversight committee approves it, where you could say, now let's look at the trajectory, let's look at this, let's look at that. And that, by the way, would be the other key thing that I did mention, but I just want to keep repeating it, which is that the beauty of any of these studies, whether they be population-based or clinical trials, is they form this magnificent database, which down the line can be used for this data mining purpose, where you can identify other interesting things like that CART method for doing screening for glaucoma. That wasn't part of the original design at all. So I think you do have to follow the guidelines of the funding agency and what the data monitoring group expects you to do. But then you could, down the line, say, let's look at who did benefit in this and blah, blah, blah. Maybe the younger people, or maybe this or that, or whatever. Yeah, so. Well, yeah, I mean, that definitely is an interesting question. The question is whether that's doable, but it certainly is worth thinking about in general. Like in this complex rehabilitation trial, so it could be in the original design that you're thinking of subgroups that might benefit more, and et cetera. But I think it has to be described prior to the funding part of it. I don't know. Carolee, do you have anything?
So I'm going back to your slide on the study cycle and treatment discovery. That is, I think, something that the rehabilitation community is really grappling with now.
Mm-hmm.
And I think part of the issue is that our science is not mature enough. We don't understand the rehabilitation process because it is so complex. And so when you run these kind of trials, a good example is the
demonstrate it.
that in the human mind.
Right.
And part of that is the complexity of the human for this rehabilitation kind of
Right.
outcome.
Right. So
We don't understand it. And I think that's where we are in
yeah. So I.
very complex interventions. And we might come from an animal model like gene therapy, but the primate model of reapplication is not a good model for the human.
Right.
The central reason after
Yeah. So the beauty of your response is that this does give the group you all ideas to think about how we can change the. You could come up with a new translational scheme number 2 for rehabilitation. So it is an interesting question and an interesting has potential for developing a new kind of way of thinking about things. Right. Well, I definitely have been familiar with this with regard to this kind of phenotypic, genotypic type thing. In other words, and kind of ties to that Chinese medicine also, which is that certain, and even in that stroke study we did with David Alexander we learned that if you're going to do this acupuncture in stroke patients, that there wasn't just one way to do it for everybody. So that's a good prototype. It was something that you would try to evaluate on a patient-specific thing, and then do the acupuncture that way. So that could be a good prototype. So I do think it's an interesting question and an important question. And it could be like the next wave of doing these things. Are there any? Yeah. Yeah, and that does fit in with the other slide that I showed that said, anytime any decision is made with regard to designing a study, it requires this kind of interdisciplinary discussion and so on. So that could be really one of the new themes of this next generation of postdocs to kind of work on and come up with strategies and so on. So that's interesting. Jim, you have any comments on this?
Yeah, no, I think it's definitely worth doing.
Yeah.
In these trials that we described, that have come out of this department, collaboration with other people, really represent in many respects the beginning of large-scale, clinical trials of rehab. There aren't that many. And we're first learning how to do these, and we're learning the hard way. I mean, when you design to really follow through with the kind of
Right.
analysis plan that we did. Now afterwards, we can learn from
Right.
it and publish sort of papers and say, okay, look, we have to do this today, fine. But now, so the other thing is that we're going to, I mean, we don't have $60 million laying around. We have to go to NIH and other agencies to get the money to do it, and they have models
Right. That's
that they are going to expect us to use. And it's going to take a while for us to be able to go past those models if we want to go to those people for
Yeah.
structure.
But I do think that it's a smart idea to start documenting the need for that. You know, for example, for this study and this study we showed blah blah blah, and it'd be nice if this was part of the original.
And one of the realities that we discovered, and I say we was really Efficacy to this, is that when you go to NIH with a proposal for a large trial, and they don't say, oh, okay, we'll fund that. They say, we'll fund that, but we want you to change this, 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 and this. And it actually is in effect an extended negotiation, especially with how programs are structured and that sort of thing. And you often end up coming out of it at the end with a very different proposal than you went in with.
Yeah.
And that's the nature of the situation we're dealing with.
You know, that's an interesting point.
It's the nature of a phase 3 trial, which ultimately is to influence policy and practice.
Yeah.
So they're going to want something that, whatever conclusion you reach, has an impact on practice, whether it's a negative trial or not. They're not going to put that kind of money into it unless it has an implication for how we practice. And right now, the practice of rehabilitation is one of the three areas where there is absolutely no standardization. It is absolutely all over the map.
That's a really interesting point.
And so we are starting with, these very tight models and approaches in our phase 3 trials, but the reality of, practice in the community is, there's really not standardized at all.
Yeah, but I could envision down the line, having a really important paper that kind of shows why this is the case and proposes like new standards for. So that could be the hot subject.
There was, there's been a lot of work using the drug progesterone
Right.
in traumatic brain injury. And this work, John Stein is one of the ones who really led this effort. And he had all of the time getting funded to do this, because the way progesterone works is there's not one target. And drug trials usually, they like to know where is the target of this. That's why you do the animal research, you put it up the mechanism.
Right.
And you say, okay, we're targeting this, and this is why it's appropriate for traumatic brain injury. And progesterone doesn't work like that. It's multiple targets. And finally, when that was acceptable, he has now been funded, and he's running a fairly large trial in traumatic brain injury. But as part of his trial, they're looking, after rehab at the outcomes of using progesterone, early, and then how do these people fare relative to the progesterone placebo. And and actually no one has defined in a trial like this what rehab is. So they just say, okay, people are going to get what they get, and we're not even going to go there and trying to find what it is.
Interesting.
So that trial is currently going on. I think it's going to be very, very interesting.
What, Yeah, so. Yeah, but now that could be done in a secondary analysis, right? Right. Yeah, you have a question, young lady? By the way, it's $3 for a question.
So maybe it's not this question, but the difference between phase 1, phase 2, and phase 3, I'm assuming that there's some standards. For example, in phase 3, if the research is talking about organ management, things like that, and doing the basic, you know, kind of comes out as standards accepted.
Yeah.
Do you include the phase 3?
Yeah, usually when you do a phase 3 trial, you have to demonstrate that you have information from a phase 2 trial. But Carol Lee probably can answer that better.
Yeah, I mean, you have to stand that. So that what is being done is being done outside of and that's, you know, that is difficult in research.
Oh yeah, so yeah, so that's an interesting point. Right, that would be a good example of why it isn't like that animal. And that would be really kind of, again, back to the NIH kind of expectation, standardization. So you don't want all of a sudden 2 centers to get totally different results from the 3rd and 4th center. But these questions are really interesting, which you all are asking here. So I think this is definitely could be one of the themes that is looked at through this famous TREET that we have. What does that stand for, by the way? I forgot what TREET stands for. Is it TREET or TWEET? Oh, I should know that, right? Because I'm a co-investigator. And see, when you get to be... That's funny. See, when you get to be my age, you kind of forget things. Like, I can't even remember my name. Am I male or female? I'm making him laugh. That's good. Okay, so it's really been a fun thing here. And look forward to... yeah.